Okay, so welcome to the lesson on how to use your TI-Nspire in order to solve a system of linear equations. And so we're going to jump right into it. What I have here on the right of the screen is the first of the examples from your note on solving linear systems using the TI-Nspire. And I'm going to go straight into showing you how to use the calculator in order to get a solution. As you hopefully remember, the solution to a linear system is, in graphical terms, a point of intersection between two lines. Okay, so we're going to go to the calculator, and what we're going to need to do start off is go to the home screen, create a new document, and what we're going to do is this time select a graph. What it does immediately is open up a box with f1 of x. That's essentially the same as y equals. That's going to be our function. And what we're going to do is type in the first of our equations into that box. So that's y equals x plus 1. The x we're going to use is down on the bottom of the screen here. So we're going to type in x plus 1 and we hit enter. And what that's done is it's graphed the line for us. One of the things that we're going to need at a later point as well is when we are representing what the calculator has produced for us, we are going to need to draw a sketch of the graph reasonably accurately. And so the other key point that we could use here is the y-intercept. If you remember from graphing lines, of course the y-intercept, since lines are in the form y equals mx plus b, the plus 1 is going to be the y-intercept. But in case you've forgotten that, you are able to go and have the calculator do that for you. So I'll show you how to do that quickly. If we go to menu and we push trace, and if you were to trace the graph, what you can do is as you move your cursor left and right, you'll see it will stop on the y-intercept. And if you just hit enter on your calculator, it will then paste the coordinates of your y-intercept there, and you then hit escape to get you out of that menu. So here I have the y-intercept of my line, and now I'm going to go ahead and graph the second line. What I need is that box that allows me to type an equation in, and the way to get that back is to push tab, and now we have the f2x, which will be my second equation. Now I'm going to type the equation in, minus x minus 3. You notice I used the negative button. If you'd use the subtract button on the TI-Nspire, it doesn't make a difference. So I'm going to hit enter. I'm going to do a couple of things, the same process. So first I'm going to trace the graph. You'll notice that the calculator is programmed to go straight to the first graph. If I just use the cursor keys and push down, then it jumps onto the other graph. Fortunately, it's jumped straight onto the y-intercept there, and so I'm going to hit enter and then escape, and now I've got my two y-intercepts. What I finally need to do is to calculate the actual point of intersection between those two. So once again, I'm going to go into menu. This time I want to analyze the graph, and what I'm interested in is the intersection. What appears now is on the bottom left of your screen this question that says where is the lower bound. So the lower bound is any point to the left of the intersection. So I move to the left and hit enter, then I'm going to scroll to the right of that and hit enter again, and there you can see it has produced the coordinates of the point of intersection for you. In other words, x equals minus 2, y equals minus 1 is the solution to this system. And so now what I need to do is transfer that information onto my graph. And so I'm going to just make a couple of marks. First of all, I have 1 as my y-intercept, and the second point I have is minus 2 minus 1 is the point of intersection. The third point I have is 0 minus 3, and that's going to very easily allow me to draw a representation of the two graphs. And so I'm going to use lines here, and I'll just show my two lines over here. So my first line and then my second line is going to go over here. And the last thing that I would be required to do would of course be to label the intersection point, which is -2, -1. Okay, and so we have now solved a system of equations using the calculator. So what I'm going to do now is go on to the next page where we have a couple more examples. These examples have got little added complications to them. As you can see in this case, to graph this straight away is going to be a little more difficult. This is detailed on your note. One of the first step that you need to take care of is to get the equations in the form y equals. In other words, isolate y. So we're going to go ahead and do that here. In this case, the 3y minus x. First I'm going to add x to both sides, and that's going to leave me with 3y is equal to x minus 6. That moves the x to the right hand side, and then I would divide by 3, and that leaves me y equals 1/3 x minus 6 over 3, which of course simplifies to 2. And then my second equation over here is a little bit easier. 2x minus y equals 7. Basically I'm going to add y to both sides and subtract 7 from both sides, and my equation will be y equals 2x minus 7. So what I'll do now is I'll go back, and what you can do on the calculator is, what we want to avoid is too many graphs on one page. It becomes unwieldy and difficult to work with. And so what I'm going to do now is I'm going to add a page to this document. So I go Control, and you see above the document button it says plus page. So that allows me to add a page, and I'm going to click on Graphs, and now I have another graphing page which is going to allow me to enter these. Okay, so I'm going to enter y is equal to 2x minus 7, and there's my first graph. The second graph, 1/3 x, so I'll push tab again, and now it is 1/3 x, or x divided by 3, same thing, minus, and if you hadn't realized that 6 divided by 3 was 2, you could always enter it exactly as you see it, 6 divided by 3, and the calculator will take care of it for you. Now what we need to do is solve the system, and so that's going to involve analyzing the graph and finding the intersection. We go to the left, we go to a point to the right of the intersection, and here we have the coordinates of our intersection point, 3 minus 1. Keep in mind, of course, we can use the calculator to find our y-intercepts, or if we already recall the key lessons from graphing lines, you should realize that we have a y-intercept of -7 for the first graph and -6/3, which is of course -2 for the other graph. So I'm going to use the same procedure. I'm going to go in and mark off 1, 2, 3 and -1. That's the point of intersection of my lines. I'm going to mark off -7, which is going to be the one y-intercept, and then I'm going to mark off -2, which is going to be the other y-intercept, and then I'm just going to use the line tool so that I can draw my graphs a little more accurately. And so I have my first line passing through those 2 points over there, my second line, oops, sorry, let's undo that, and we've got the second line passing through those 2 points, and of course, last but not least, I now need to write in the coordinates of the point of intersection, which is of course the solution to the system. All right, and the final example, a little more tricky. What we're going to need to do, as we did in the previous example, is to isolate y first of all. So I'm going to go ahead and do that. For this equation on top, I'm adding 2x to both sides, and so that's going to rearrange to y is equal to 2x minus 6. For the equation beneath that one, our second equation over here, I will be adding y to both sides and subtracting 19. And if I do that, I'm going to get y is equal to 3x minus 19. Now hopefully you're able to spot straight away that on this axis we don't have any values, and you can see, or hopefully you realize that's because we have a y-intercept of minus 19, and so that's going to be pretty far down, and I've included this example so I can show you how to deal with this on the calculator. Okay, so let's go through back to our calculator. Once again, what we're going to do is we're going to add a page. If you wanted to, you can see here with the numbering, that's where I did my first graphs. Here are my second graphs on the second page, and I'm going to add a third page. So once again, control document, that's going to add a page. I want a graphing page, and I'm going to go ahead and enter my equations. 2x subtract 6. There's my first equation. The second equation that I'm going to enter, so tab 3x subtract 19, hit enter, and what you can see, the problem that we face right now is that the point of intersection of those two graphs cannot be seen at this point. And so what we need to do is modify the window. So this is mentioned in your notes, and I'm going to show you how to do that now. In order to do that, there's a couple of different ways of doing it. So I'm going to go to menu, and you'll see one of the options is window, and I'm going to go up to window settings. This is the x value, so minus 10. What I'm going to do is tab to the next line, and I'm going to increase the x values. I'm going to move that up to 25. I'm then going to tab down. The y minimum is not going to be the problem. We can hopefully see that the graph is moving towards each other, and what it's going to do is intersect somewhere in the top right hand corner of my graph. So I'm going to tab again, and I'm going to increase that to 25 as well, and we'll see how that works. So in this case, what you can see is I increased the value of the y and the x, the positive x and y, and I'm now in a position where I can more clearly, or rather I can actually see the point of intersection over there. And so now I'll go through the same process. Menu, analyze graph. I want the intersection. Go to the left, go to the right, and there I have my intersection point. And once again, we now transfer this information onto the graph. Be aware of what the scale is going to be in this case. But as long as we have a reasonably accurate graph, then we're going to be okay. So I'm going to go very quickly before I run out of time for the video. So I'll just rush this a little bit. So I'm going to go up 2, 3, 4, 5, 6, 7. Alright, so I'm going to just go up in increments of 5. So I'm counting each of the 2 blocks as 5, which is going to give me 20 over here. And then for the x's, 5, 10, and 15. I'm going to mark that as 15. The x-intercept, the point of intersection is at 1320, and so I'm just going to put an estimate in there, label it as 1320. I'm going to have my y-intercept over here. The first of the y-intercepts was at minus 19. The other one was at minus 6. That's going to be about over there. And I'm just going to join those very quickly. And so we have our first line over there, and our second line over there. And that takes care of solving systems of equations using the calculator, and you can now turn your attention to your assignment.